Students, now in this video we're going to see the chemical property of alcohol, which is very important. So let us go with it. So the first chemical property of alcohol is acidic nature of alcohol. Do remember, though alcohols are alcohol, but they show acidic nature. Okay, and you know that in alcohol there is R group, that is called alkyl group. In alcohol there is R group because the general symbol is ROH. So that R is referred as alkyl group, which shows plus I effect. The meaning of I is inductive effect. I means inductive effect, and plus I effect means to give electrons. So the alkyl group present inside alcohol, they donate electrons towards oxygen of alcohol group. So they show plus I effect, we say. Okay, now you can see out here, students. So this is CH2 linked with OH is primary, CH linked with OH is secondary, and C linked with OH is tertiary alcohol. CH2 linked with OH is primary, OH linked with CH is secondary, and OH linked with C is tertiary. When you put here C, carbon valency has to be made 4. So we write 1, 2, 3, 4, and we put 3 alkyl group. And if you see here CH is there, so we put 2 R out here. And when the CH2, we put 1 R to make the valency of carbon 4. So this is the general formula for primary alcohol, general formula for secondary, and general formula for tertiary alcohol. And as I said you, alkyl group R, it shows plus I effect, means they give electron. Plus I effect means plus inductive effect, means to donate electron towards oxygen. So this R will donate electron towards oxygen of alcohol group. And here also there are 2 R, so it will donate from 2 sides electron to the oxygen. And here are 3 R, so oxygen will get electron from 3 sides, from 3 alkyl group due to plus I effect. Plus I effect means to give electrons. Okay, to R will give electron to oxygen, that is plus I effect. Now if you see out here oxygen is getting electron from 3R. So obviously the population of electron, already it has 2 lone pair, oxygen has 2 lone pair always, and it is getting some more electron from the alkyl group, that is R. So here the electron density is what? More. Okay, electron density becomes more, and O-H bond becomes stronger, whereby it will not dissociate to produce H plus ion. Therefore, it shows weak acidic nature. I repeat again, here the electron density becomes more because the 3R is giving electron to the oxygen. So this is tertiary alcohol. So the electron density, don't say population, we say electron density on oxygen atom becomes more. And as the electron density becomes more out here, this bond becomes stronger. OH bond becomes stronger and does not break down to produce H plus ion. Therefore, tertiary will be the weak acidic character because they don't dissociate easily to produce H plus ion. So electron density is not less, it should be more on oxygen atom, and OH bond becomes stronger. As a result, it will not dissociate to produce H plus ion. Therefore, tertiary alcohols are referred as weak acids. They show weak acidic character. But as compared to this, if you see out here, there are 2 R giving electron. So here the electron density as compared to this will be less, whereby electron density in oxygen atom will be less as compared to tertiary. So this bond is weaker than tertiary. Therefore, it breaks down easily to produce H plus ion. Therefore, secondary alcohols shows more acidic character than tertiary. Now finally, here if you see, there is only 1 R giving electron to the oxygen due to plus I effect. Plus I effect means electron donating effect. So here if you see, the electron density on oxygen atom as compared to here and here will be less. Electron density is what? Less. And as the electron density is less, this OH bond becomes weaker. Not stronger, it will become weaker. And it can break down easily to produce H plus ion. Hence, primary alcohols are more acidic than secondary and tertiary, students. So I repeat the whole thing once again. To remember, alkyl group present in alcohol shows plus I effect, plus inductive effect means electron donating effect. So in tertiary alcohol, alkyl groups are more, so they give more electron due to plus I effect, and electron density out here becomes more. And as the electron density on oxygen atom becomes more, OH bond becomes stronger, does not break down easily to produce H plus ion, whereby they are weak acid. Whereas in primary, there is only 1 alkyl group, so the electron density on oxygen after giving electron will be less as compared to secondary and tertiary. So OH bond becomes weaker and it breaks down easily to produce H plus ion. Therefore, primary shows more acidic character than secondary. Secondary shows more acidic character than tertiary. So if you have to see the decreasing order, so we can say like the decreasing order of acidic character. Primary alcohols are more acidic in nature than secondary, and secondary is more acidic than tertiary. So primary alcohols are stronger acid than secondary. Secondary is stronger acid than tertiary. Reason, hope so you all understood, because of R effect. Okay, so reasoning is given out here. You can make the notes by yourself for it. And do remember, it may come in MCQ question. Among the following, which is the weaker, which was weak acidic character? Primary, secondary, tertiary alcohol, none of this. So the answer is tertiary alcohol. If I say stronger, it will be primary. Okay, you can repeat the video to understand better. So we have finished the first chemical property of alcohol, that is acidic nature. Now we go to the next one, and that is reaction with sodium. Now students, you know that alcohol is what in nature? Acidic. You have learned in class 10, whenever acid reacts with metal, hydrogen gas is liberated. So let us consider this alcohol as an acid right now. So because it shows acidic character, tertiary shows least, primary shows the highest acidic character. So let us assume that it is showing acidic character, this alcohol. So when you react with metal like sodium, hydrogen gas is liberated. So remove hydrogen gas from here, this H will come out as hydrogen gas. Okay, but here is 2 hydrogen. You can balance it by writing 2 here. So 2H balance. Now what is left here is 2 RO. Here what is left is 2 RO. So I wrote 2 RO. Then in place of this H, Na will go here. So how many Na is entering? 2. So we write here 2 to balance. Hope so you all understood till here. So in that way what we get is sodium alco oxide. Sodium, R is called alkyl, but here we call alco oxide. Sodium alco oxide with hydrogen gas. So do remember, in this reaction it is proved that alcohol shows acidic character. Whenever acid reacts with metal, hydrogen gas is liberated. Similarly, when alcohol reacts with metal, they liberate hydrogen gas. Therefore, in this reaction it is showing acidic character, students. Now let us take a particular example. Alcohol is alcohols. R I replace with CH3, CH2 means ethyl. So this became ethyl alcohol reacting with sodium. So whenever any alcohol which shows acidic, all acid alcohol shows acidic character, reacts with metal like sodium, which gas is liberated? Hydrogen gas. Then what will be left here is this one, CH3, CH2O. This H will get removed as hydrogen gas. And to fulfill the place of this H from here, what will come? Na. Now to balance this is 2H. So here is 1H. So put here 2. So 2H, 2H balance, 2 ethyl oxy, 2 ethyl oxy balance, 2 Na, 2 Na balance. And the compound so formed is called sodium etho oxide. Sodium etho oxide. So this reaction proves that alcohol shows acidic nature. Okay, reaction with sodium. So far we have finished 2 properties, students. In the first property we saw the acidic nature of alcohol due to R showing plus I effect, and number 2 reaction with sodium. Okay students, now we go to the third property of it. Now the third property of alcohol is esterification reaction. It's a very important reaction. One question has come in your board exam, that we'll discuss later. Okay, so let us see what is esterification reaction. It's a very important reaction. You have to take acid and alcohol and you'll react in presence of dehydrating agent like sulfuric acid. It is a reversible reaction. So we have taken one acid, COH means acid. In general we write R, COH, acid. ROH is alcohol in general, and concentrated sulfuric acid is used as dehydrating agent. So do remember, whenever you do esterification reaction, you have to take one as acid, one as alcohol in presence of sulfuric acid as dehydrating agent, the one who removes the water molecule. And it is a reversible reaction. So since this is a dehydrating agent, so take out H from here, that goes with OH from here, H2O, water out. Now what is left here? RCOO, RCOO, and this R will come in place of this H. And COOR means ester, and all ester have sweet smell, they have fruity smell. So since ester is formed, that's why the name of this reaction is esterification reaction. So whenever acid reacts with alcohol in presence of dehydrating agent like sulfuric acid, water gets removed, H2O, and we get ester which has sweet smell, fruity smell. And since ester is formed, that's why the name of this reaction is esterification reaction. In this reaction, sulfuric acid acts as dehydrating agent, and it is a reversible reaction. Now let us see one particular example of each, students. Now R I replace with CH3. When I replace R with CH3, it becomes acetic acid, and here I am replacing R with C2H5, that is ethyl alcohol. Now again this is a dehydrating agent, so from here what will come out? H, and from here what will go out? OH. So this H and OH comes out to form water. Then this ethyl will go in place of H, and as this ethyl goes in place of H, you get C2H5 in place of this H, CH3COO, C2H5, and this came from acetic acid, so we write acetate, and here is ethyl, so we call it ethyl acetate. Okay students, so this, the compound name is ethyl acetate, which is a ester which has a sweet smell, which is an ester which has a sweet smell. So any acid reacts with any alcohol in presence of dehydrating agent like Kong sulfuric acid, you always get ester, and such reaction is known as esterification reaction. And the esters so formed, they are volatile in nature. We get sweet smell, but the smell does not last forever. It is volatile in nature. Afterwards it will vanish. Okay, so one question has come in MCQ in the sample paper of the board exam, and in that this question was given, there is a compound A which reacts with ethyl alcohol in presence of Kong sulfuric acid to give a fruity smell or sweet smell. Who is that compound? Answer was acetic acid. Okay, answer is CH3COOH for it. Hope so you all understood. Now we go to the number 4 property of it. Number 4 property is reaction with hydrogen halide. Hydrogen is hydrogen, halide symbol is X, so HX. Reaction with hydrogen halide, so we can write HX. Now look out here. This X can be replaced with I, this X can be replaced with Br, this X can be replaced with Cl. But when you write HI, Br and Cl, do remember HI is more reactive than HBr, HBr is more reactive than HCl. So if you see the reactivity order, hydrogen iodide is more reactive than hydrogen bromide than hydrogen chloride. Now you can see this is your ethyl alcohol, CH3CH2OH, ethyl alcohol, reacting with hydrogen halide. Which one I have taken is HCl. Using catalyst like anhydrous zinc chloride, and we have to heat. Okay, and this mixture of HCl and anhydrous zinc chloride is known by the name Lucas reagent. The mixture of these two is known by the name Lucas reagent, and this is used in concentrated form. So when you do so, from here OH will take this H on heating, and what gets removed is water. As water gets removed, what is left here is CH3, CH2, that goes with the Cl to form ethyl chloride. Ethyl chloride. So this is one of the reaction with hydrogen halide, taking HCl. Now the other one, now this is your secondary alcohol, because OH is linked with CH. OH linked with CH is secondary alcohol, and the formula is CH, CH3CH3OH. CH, CH3CH3OH is known by the name isopropyl alcohol. OH is linked with CH2 is a secondary alcohol. Now again you are adding Lucas reagent, Kong sulfuric HCl, Kong HCl and anhydrous zinc chloride, and you are heating at room temperature. Okay, now when you do so, this again OH will go with this H to form water, and as this goes out as water, now what is left here? CH3, CH, CH3 is left. Now in place of this OH, from here Cl will come, and we get isopropyl, chloride. Okay students, now we go with the next one. Now CH3CH3CH3OH is called T-butyl alcohol. There are 4 carbons, so butyl alcohol. But why T? OH is linked with C. OH linked with C is tertiary alcohol, so that's why T. Now again, when you add Lucas reagent, Kong sulfuric acid and anhydrous zinc chloride at room temperature, this OH will go with this H to form water. Now what is left in tertiary alcohol? CH3, CH3, CH3 dash. Now in place of this OH, from here Cl will come, whereby we get T-butyl chloride. T-butyl chloride. Now if we have gone through Lucas test, which I taught you in the earlier portion, so when you add Lucas reagent, Kong sulfuric acid and anhydrous zinc chloride, to alcohol at room temperature, the one which gives cloudiness or turbidity immediately is tertiary alcohol. So this is the formula of that cloudiness and turbidity. The one which we give after few minutes is secondary alcohol, and this is the formula of the cloudiness or turbidity appear for secondary. But you know that primary alcohol 1 degree does not give cloudiness appearance at room temperature. We need to heat. So when you heat, it also gives cloudiness appearance, and this is the formula of that, that is ethyl chloride. So do remember, when primary alcohol reacts with Lucas reagent on heating, whatever cloudiness turbidity you get We have already done that. That is of ethyl chloride. In secondary, that is of isopropyl chloride. And in tertiary alcohol, when you get cloudiness or turbidity appearance, that is of T-butyl chloride. So primary alcohol will give you primary alkyl chloride. Secondary alcohol will give you secondary alkyl chloride. Tertiary alcohol will give you tertiary alkyl chloride. And you can see here, chlorine is linked with C. So tertiary chlorine is linked with CH. Secondary chlorine is linked with CH2. So it's primary. So from here, always remember when you add Lucas reagent to the three unknown bottles, the one in which cloudiness turbidity appears immediately is tertiary alcohol, and that cloudiness turbidity is because of the formation of T-butyl chloride. For secondary, it's due to the formation of isopropyl chloride, and for primary, it's ethyl chloride. Now we have seen enough reaction of HCl with primary, secondary, tertiary alcohol. Now let us see the reaction of HBr with the alcohol and HI. Now when you react with HBr, that time we use the catalyst conch sulfuric acid, not anhydrogen chloride, but we use conch sulfuric acid, which acts as a dehydrating agent. So here this OH will take this H again to form water. Then this ethyl will take Br to form ethyl bromide. So this is the reaction of alcohol with HBr. Now let us see the reaction of alcohol with HI. As I said you, HI is highly reactive. HI is highly reactive as compared to HCl and HBr. So if you react with HCl, you get alkyl halide. If you react with HBr also, you are getting alkyl halide. But when you react with HI, being highly reactive, okay, you will not get alkyl halide, but you get alkane. Now let us see how. So when you react alcohol with HI in presence of red phosphorus, this reaction is important because it's a unique one. Red phosphorus is a catalyst here. So when you do so, look out here. 2I from here will come out as I2. Out of 2H, 1H will take this OH and 1H will form water. Now what is left here? C2H5, and 1H which is left will come here to form H6. I2 will come out separately. 1H will go with OH to form water. 1H is still left here. C2H5 with 1H will give you C2H6, which is ethane. So this reaction is very, very important. Do remember, students. You can take the screenshot of it. So by this we came to the end of the four chemical property of alcohol. From fifth, we will do it in our next video, and that is reaction with acid chloride and acetic anhydride. So this will, from property number 5, we will see in our next video. Thank you very much, students.